So I like to talk about Spartans, which I'll have an example a little bit later on. How do you kill a Spartan? Well, you have an arrow that has to fly through the air, and it has to hit the Spartan in order to kill a Spartan. If you've watched 300 recently. Okay, and so how do you kill a Spartan exactly? Well, number one, it has to actually hit the Spartan, so it has to collide. Number two, it has to collide and it has to hit with enough energy. If it's too weak, it's just going to bounce off his helmet. And the third thing is it has to hit in the right place. So if you hit his arms or his legs, you won't actually kill the Spartan. So it has to be probably on his body or head somewhere. Okay, and so that's how you kill a Spartan. All right, so it has to hit with enough energy, has to hit in the right place. And so that's exactly how chemical reactions work. So it's basically kinetic energy and particles put together. That's what the collision theory is. So the particles must collide. All right, the particles must have enough kinetic energy. They must have enough energy. And so this is to do with breaking the initial bonds. And that's actually called activation energy. And you'll see this later in later videos explained in more detail. So that's the initial energy needed for the reaction to get started. And that is actually related to temperature, but don't worry about that too much until we get to it. And the particles must collide in the correct alignment. So I've often put correct 3D orientation. I've kind of used that from now on, actually, and that's not even in this first one. And this correct steric is another way you can say it. Steric 3D arrangement, steric orientation, all of those things will be okay. Okay, so if you can increase the collision of the particles, if you can increase the amount of energy that the particles have or decrease the activation energy, and if you can, if they collide more, there's a better chance that they'll hit in the right place and react.